If BE is parallel to CD and BC equals AB equals 3, so both are 3, and CD equals 10, what is the area of trapezoid BEDC? BEDC. Okay, now since they are parallel, I can say this angle is the same as this angle, and this angle would be the same as this angle. Now since they both share this angle, which I don't know the value, let's say theta, okay, then they are similar triangles, right? They are in proportion. They have the same three angles: alpha, beta, and theta. Alpha, beta, and theta. Okay, so since this side is half of this side, then the proportion is 1 to 2. The same goes here. Sorry, AE is 4. This must be 4 also, right? Because it's from 1 to 2. And since 10 is the length of CD in the big triangle, that means that in the smaller triangle, it corresponds 5. Now, I have the length 3, 4, and 5, but I don't know if this angle is 90 degrees. The Pythagorean theorem works both ways. If I have a triangle, let's call this A, B, and C. If the angle is 90 degrees, then A squared plus B squared equals C squared. Now, if I didn't know the angle, but it is true that A squared plus B squared equals C squared in the triangle, then it must be true that the angle is 90 degrees. The same here, 3, 4, 5, they make this true. 3 squared plus 4 squared is 5 squared. Therefore, the angle must be 90 degrees. That's the only way that it can be true. So theta actually is 90 degrees. And if I want to know the area of the trapezoid, instead of going for the base and the height of the trapezoid, I can do a difference of triangles. I can do the big triangle minus the small triangle. That gives me the base, which is the trapezoid. So the area would be, since this is 90 degrees, I can take one side as length, as base, and one side as height. That would be 6 times A divided by 2 minus 3 times 4 divided by 2, and that would be 24 minus 6, and that is 18. So letter B.